Hello friends, welcome to G-Centric. So in this lecture we will continue with the problems based on the power and power factor. Okay, so the given question is, the voltmeter reading is given by these three values V1, V2 and V3. We have to find the load power factor, and when RL is given, which is equal to 5 ohm, we have to find the power consumed by the load. Okay, so now you have got V1 here, V2 here and V3 here. So we know V3 is the load. Okay, so this is load. So now to find out what is load power factor, it is nothing but cos phi. Okay, so what we can do, we will draw the phasor diagram of this one. Okay, so now if I draw phasor diagram, see here, if first it will enter, if the current is I, then first it will enter, okay, we will sell it IL. Since it is series, same current will flow here also, IL. Okay, so when it enters resistive network, so what it is, V and I are in phase. Okay, so this is the phase. Okay, this is IL and this is VR. Okay, or you can take V2 because we have got V2. Okay, now it enters the load. Okay, so it is inductive. Okay, R plus L, it is inductive, but since it has got some internal resistance in it, the inductive circuit, so it will not lag by 90 degrees. So there will be some angle called as phi. Okay, by some angle phi. So what is this portion? V3. Okay, so now if I draw it neatly, okay, so I will take it here. Here it is V2. Okay, since it is resistive, they are in phase, and this is V3 lagging by angle phi. Okay, since inductive voltage leads, okay, current will be lagging. So we are taking with respect to voltage as reference. So now from parallel law of vector addition, okay, we can extend this line. Okay, and this also. Okay, so when they join it here, the diagonal of this one from these two vectors will give me the value of V1. Okay, so now this magnitude of V1 is here. So we have got V2 as well as V3. Okay, so this phi is what? It is the angle between V2 and V3. So basically V2 and V3. Okay, and also angle between IL and V3. Okay, IL and V3. So phi is the angle between IL and V3, and cos phi is nothing but this phi denotes the angle between voltage and current. So first we will find out the magnitude. Okay, so the magnitude we can write it as V1 equal to under root of V2 square plus V3 square plus 2 times of V2 V3 cos phi. Okay, so this is from the parallelogram of law of addition. Okay, so now we know all the values V1, V2, V3, only the unknown is cos phi. Okay, so we will substitute whatever we have, we will square it on both sides. So this is 220 square. Okay, this under root will not come. Okay, we have got V2 as 122 square plus we have 136 square plus 2 into 122 into 136 cos phi. Okay, so when you solve this, cos phi will come out to be 0.45. Okay, so this is the load power factor that we have got. So now we have to find the power consumed by the load. Okay, so we have RL and as well as XL. Okay, so now power consumed by the load when RL is given as 5 ohms. Okay, so I'll rub this one. I'll note down the value of this as 0.45. Okay, so power is nothing but it is I square RL. Okay, so what I'll write, power is equal to IL square RL. Okay, so now I don't know what is IL, what is current, I don't know, but from this one from this, if I have to convert this into Z, that is impedance, then what I have to do? So Z is equal to total current R plus JXL. Okay, but I know that cos phi is, we can also write this cos phi as resistive upon impedance, right? So cos phi we know 0.45, RL we know, so I can find ZL. It is 5 upon 0.45. So I will get approximately the value of ZL as 11.11 ohm. Okay, so now to get the IL load, what I can write? IL will be equal to V3 upon the impedance of the load, right? Okay, so now V3 I know, that is 136 volts. ZL I found out. Okay, so it comes out to be 12.24 amperes. Okay, so the current, we found the value of the current. So now if I substitute the value of current in this one, 12.24 whole square into load RL. So value of RL is 5 ohms. So you will get approximately 750 watts. Okay, so it is the power consumed by the load. Okay, so this is like they have given you V1, V2, V3. Okay, when you make the phasor diagram, okay, this load has got internal resistance RL, so this angle will not lead, V3 will not lead by 90 degrees. Okay, so but it will lead by some angle phi. Okay, so we will move on to the next question. Okay, coming to this question. Okay, so this is question number 15. Okay, so in this question we have to find IRMS, okay, which is given over here. Okay, so this is IRMS, we have to find that value. Okay, so we have got R1 and R2 and R3 resistors. Okay, so this type of thing we have seen in the equivalent resistance in DC circuit. Okay, so there all the resistors were equal. So if it was equal, then we would have directly done it as 5/6 R. Okay, so basically we have got 3 resistors, R1, R2 and R3, so we cannot do that. Okay, so now what I can do is, I will take the current as I. Okay, we will calculate IRMS later. So we will take this as voltage V and the current entering as I. Basically I will be equal to IRMS later when we take by root 2. Okay, so this I gets divided into 3 branches, R1, R1 and R1. So all 3 resistors are equal. So it gets divided into I by 3. Further when it comes here, okay, here also it is I by 3. We have R2 in this one and R2 in this branch. So it will be I by 6. Okay. So now here also we will get same thing, I by 6 and I by 6. So now this I by 6 and I by 6 again they will flow in this branch. Okay. So it is nothing but 2I by 6. So it will be again I by 3. Okay. So now what I need is total current I. So basically it is given by V R equivalent. So now if I move choose a loop, okay, if I take this path, okay, I will move into KVL. Okay, so how if I, this is minus and plus, okay, so here it is plus minus polarity. Okay, I'll move around the KVL in the outer loop. So for that, so this implies nothing but applying KVL. Okay, so from here to here it is plus V. Okay, so coming forward we have minus I by 3 into, what is the value of resistor R1? 3 kilo ohm. Okay, so 3K. Then again we have here I by 6 into 6 kilo ohm. Then minus I by 3 into 9 kilo ohms. Okay, so this will be equal to 0. Okay, KVL sum will be equal to 0 around a loop. So this 3 get cancelled. Okay, so minus 3I minus 4I minus 5I. So this is 5K, right? Yeah. So 5 kilo amperes basically. Okay, so this it will be nothing but, if I substitute here in this one, so what will the value that I will be getting? So I will be equal to 10 sin t. Okay, so this is phi I. Okay, I missed that one. So phi by Vi is nothing but 5 kilo ohms. Okay, that is the equivalent, R equivalent we have. So V by I is nothing but what? It is R equivalent. Okay, so I will substitute this R equivalent here. Then I will get 2 sin t. Okay, 2 sin t, 5 ones are 5 twos are milliamperes. Okay, so now to find out the, okay, so I will rewrite that equation here. I is equal to, how much we got? 10 sin t upon 5 kilo. So this gets cancelled. So we have 2 sin t milliamperes. Okay, so now we want only IRMS. What we want? IRMS. So IRMS, we know that. Now if I redraw that circuit, okay, replacing whole of the equivalent by R equivalent. Okay, so the circuit will be somewhat like this, with this as 5 kilo ohm. Okay, so this is diode and we have got V, that is 10 sin t. Okay, so now this diode, whenever we have a diode and a AC circuit, okay, so the sign will be like this waveform. So if the polarity is like this, we will get plus and diode will be in active mode. So when the waveform changes to negative, here the polarity will also change, and in this case the diode will not conduct. So what will be the output we get is half wave rectifier. Okay, so this will be the half wave rectifier. Here it is I of t, and what is the magnitude we have? 2 milliamperes. Okay, so now we know that IRMS of a half wave rectifier is nothing but Im upon 2. Okay, so this is 2 means here also we have 2 milliamperes upon 2. So what you will get? 1 milliampere. So this is like, you have to, whenever you do not have equal resistance, so whenever you don't get the correct formula, like equivalent formula for equal resistance, take the I as your reference, then divide it according to the values of the resistors. So somewhere there will be a cliff given, then most of the time it will be like applying KVL in the outer loop. Okay, so we will move on to the next question. Okay, coming to this question, first thing, it was asked in GATE 2016 electrical branch. Okay, so we have RL, VS supply is given. Okay, we have IS, IRL and IC. So all the current values have been given here. Only we have to find IC, which is given in the second question. And the first question says power dissipated in R. Okay, so what is the power dissipated in R will be? It is nothing but IRL square into R. Okay, so because IRL square, because it's in series, so same current will be flowing in the circuit. So now we know that we have got VS over here, okay, and we have got IRL current. So what we can write? Which is equal to, we will take it as R equal to Vs upon I, RL. Okay, so how much is Vs we have? 1 angle 0 degrees. Okay, and what we have got? IRL root 2 minus pi by 4 degrees. Okay, so now I will take 1 by root 2, I will keep it as it is. Angle will be pi by 4. Okay, that is 45 degrees. So now this I can write it in the form of, so in what form I can write? It is nothing but, basically this is not R, this will be total Z. Okay, so impedance R plus JXL. So across this we have got total voltage as Vs. So directly we cannot take Vs because there will be some voltage drop here in the R. Since we do not know what is the value of R, directly we cannot take it. Okay, so we have to we have got this as Z ohms. So now this can be split into 1 by root 2 cos 45 degree, pi by 4 is cos 45, then plus j 1 by root 2 sine 45 degrees. Okay. So now cos 45 is also 1 by root 2. So I will write it as 1 by root 2. So sine 45 is also 1 by root 2. Okay. So this comes out to be 1 by 2 plus j 1 by 2. So what it is? Basically impedance. Okay. So this is real part and this is imaginary part. So real part will go with resistor and imaginary part will go with inductor. So now we know what is the value of R. Okay, 1 by 2. So IRL we have to take only the magnitude while calculating the power, and we have root 2. So basically root 2 whole square will be, this is P equal to root 2 whole square into value of R is 1 by 2. Okay, so 2 gets cancelled and we have got 1 watts. Okay, so now coming to the second question, we have to calculate the value of current IC. So directly we cannot apply KCL over there. So but we can write it as IS will be equal to vector sum of IRL plus IC. Okay, so we have to find IC. So it will be IS minus IRL. Okay, so I can substitute the value of IS as root 2 pi by 4 minus what is IRL? Root 2 angle minus pi by 4. Okay, so now again I can expand this one. So root 2 cos 45 degree plus j root sine root 2 j root 2 sine 45. This also I can write minus root 2 cos 45. Okay, so here also what I can write, minus into minus plus j sine 45 root 2 sine 45. Okay, so this gets cancelled with this one. So we have 2 root 2, okay, 2 times of root 2 sine 45. Okay, so what is sine 45? It is 1 by root 2. So this that cancels and the answer is 2J amperes. Okay, 2J ampere is the answer for this question, IC. Okay, what will be the angle? Since it is a pure capacitive network, it will be having angle of 90 degree. So this J is nothing but one angle 90 degrees. Okay, you can write in this way. This is amperes, 2J amperes. So this all the options were given. It was given in the options, but in terms of imaginary, or else if they have asked the magnitude directly, you could have magnitude here and take the square root of this. Okay, you will get the answer. Since the options were in imaginary terms, we will do in this method. Okay, so we will move on to the next question. Okay, so coming to the 17th question, we have got voltage across the load is V of t. Okay, 60 cos omega t minus 10 and current also is given. So what we have to find? First thing, real and reactive power, then apparent and complex power, power factor and circuit impedance. So first one we'll find it out, real power. Okay, so real power is nothing but Vrms, Irms cos phi. Now to find the value of cos phi or the phi angle, okay, so we will draw the phasor. This is 0 degree reference. Okay, so Vt is minus 10, minus it moves in the clockwise. Okay, this is minus 10 and it is plus 50, so going in the anti-clockwise is 50. So only we have to consider the magnitude, not the sign. So phi will be equal to 60 degrees. Okay, so directly you cannot just tell 10 or 50 or something. Okay, so you need to draw the phasor diagram, take the reference 0 degree, add it up. Okay, so next substitute in the Vrms and Irms. So here we have got maximum value. So what will be Vrms? 60 upon root 2, angle is minus 10 degree. Okay, since they both are in cos, so there won't be any difference in the angle. If one was in sin, then we had to convert the other in cos or sin term. Okay, so since they are same, we will keep it as it is. And what is IRMS? This is in volts. 1.5 root 2 and the angle is 50 degree. Okay, so now I'll substitute here 60 by root 2 minus 10. Okay, so we have to take only magnitude. Okay, IRMS is 1.5 root 2. So what is the angle between VRMS and IRMS, or voltage or current? It is 60 degrees. So cos 60. So what is cos 60? It is 1 by 2. So 60 by into 1.5 to 1 by 2. Okay, so this 2, this 30. Okay, so 30 means it will become 45. 45 divided by 2 is 22.5 watts. Okay, next we have to calculate reactive. Okay, so it is VRMS IRMS into sin phi. Okay, so what is the value of phi? 60 degree. So here also we will get 60 into 1.5 into root 2, but this sin 60 is root 3 by 2. Okay, so this is 22.5 into root 3. So you will get the answer as 38.97 volt ampere reactance. Okay, so next we will move on to the second question, apparent power. So apparent power is nothing but denoted by S, which is equal to VRMS into IRMS. So VRMS is 60 by root 2 into 1.5 by root 2. So this answer you will get as 45 degrees. Yeah, 45 watts. Okay, so this is the apparent power. Now you have to find the complex power. So I'll rub this phasor. So this reactive. Okay, so we will have to find what? Complex power. So it is denoted as S bar. Okay, so how we will find? One is P plus JQ. Okay, substitute the value of P. How much we had got? It was 22.5 plus J into Q, 38.97. Okay, so take the magnitude of that and angle, you will get complex. Or there is one more formula for this one. So VRMS IRMS conjugate. Okay, so whatever imaginary term will be there, it will turn to, if it is negative, it will turn to positive. If it is positive, it will go to negative. So here in this case, the angle will change. We have 60 by root 2 into 1.5 over root 2 minus 50 will become plus 50. So here we had angle minus 10. Okay, so this answer comes out to be 45 angle 50 minus 10 minus 50, right? This was plus 50 here. So this conjugate, what will happen? It will become minus 50. So 45 minus 10 minus 50 is minus 60 degree watts. Okay, so this is the answer for the second question. Coming to the third one, we have to calculate the power factor. Okay, so we know what is for power factor? Cos 60. Okay, so this was easy. This cos 60 is nothing but 1 by 2. Is it 0.2? Yeah, so it is leading. Which is leading? 50 is leading, right? So that is because here is 0 degree, this is minus 10. What is minus 10? V. Okay, and this is current, which is 50 degree. Current is leading the voltage. So this is possible for only capacitive network. So what you will write here? Lead. Okay, 0.5. 0.5 lead. Okay, next we have to calculate impedance. Impedance is nothing but V RMS upon I RMS. Okay, so VRMS is 60 by root 2 and IRMS is 1.5 root 2 plus 50 degrees. Okay, so when you solve this, it comes out to be 40 angle plus 50 minus will go up. So it is minus 60 degree Z, it is in ohms. Okay, so this is the solution for this problem. So we will see one more question based on this. So coming to this question, we have got V of t as well as I of t is given. So this is plus. Okay, so now we cannot use the formula that we have learnt in the IRMS to calculate the RMS. Okay, so in that we had seen that if they have the same frequency or different frequencies, we can solve the under root taking magnitude upon root 2 whole square. But in this case we cannot do that because here we have one component of voltage and we have three components of current. Okay, so 1, 2 and 3. Okay, so what we have to find? Average value consumed by the load. So average value is nothing but P is equal to Vrms Irms into cos 5. Okay, so but we cannot take directly because two components of the voltage are absent. So when they are absent, even the two components of the current will also become 0. So we are only left with this much. Okay, this component of the current. So now what is the angle? So omega t we will take V as reference and it is minus 60 degree. So current is downwards. Okay, it is 60 degree. So current is lagging voltage. So it is inductive network basically. So now we have got 60 as the phi angle between voltage and current. Okay, so we will substitute Vrms is 100 by root 2 and current is 10 by root 2 and cos 60 I will take directly as 1 by 2. So this 2 and this 5 and this one 50. So 5 is a 25, you get 250 watts. Okay, so the answer is 250. Okay. So whenever you have to check whether they have the equal number of components. Okay, so then only you can apply the formula whole root of under root of 10 upon root 2 whole square plus 2 upon root 2 whole square, like that you can continue. So when there are equal components of voltage as well as current. Okay, so in this lecture this is about the sinusoidal steady state. We have completed one chapter. Next we will see the concept of the resonance. So what is resonance? Basically it when XL will be equal to XC. Okay, so we will see this condition. Okay, in the next lecture we will continue with that. Okay, thank you.